What is the difference between GIS and Google Earth? Because I'm sure you've heard people in your organization saying, but I can do that in Google. Well, it's quite simple. Google will offer you and tell you where a shop is, and maybe even give you the directions how to get there. But as Liesl previously spoke about, what is telling you where you should place your next store? So the story that I'd like to tell you about is one of a project that I was involved in 3 years ago, which was a project for the Southern African Power Pool. You might not be aware of this organization. It is 12 countries in Southern Africa. It's part of the SADC initiative, and it's about producing power in one country and wheeling it to another country for it to be used. We have had a project called Cahora Bassa for 27 years, where we have got power from a dam in the north of Mozambique, and they want to try and investigate what other options are out there to be able to do something similar. We know we're in a power issue. We've experienced it last week. But there's options out there to look at producing power in different countries and moving it around as and when required. So we had 14 customers. We had the World Bank, we had SADC through the SA South African Power Pool, Southern African Power Pool, and I had 12 countries, starting in Tanzania and going down to South Africa. So that was how the type of customers I had. And what we needed to do is, and I'm taking from what Sean said earlier, we have this concept of data through information, through knowledge, through insight into wisdom, and I've added that concept of action or impact. How do we take this and turn it into impact? The reality is that most of the time what we're doing in our systems is documenting them and creating an asset management system. A what? What are the relationships between the data? How do we start moving beyond that into maybe potentially what are the principles, what are the underlying factors, what is best, and then what is the direction we need to follow to be able to move forward? We had a problem statement that stated the following. I have 12 countries with all their challenges. I have the power, the sources of power. So that second point is the sources of power. The nuclear, water, hydro water, solar, coal, etc., etc. Then I had who are the users of power, or your agriculture, or your mining, or your urban, etc. And then constraints, because everything has a constraint. The shorter the power line, the cheaper it is. And then things like limitations. We do not want to cross those areas that Craig Beach was speaking about earlier. So what are the limitations, and where can we go and where can't we go? This is just an illustration of the type of data that I had. This is 72 data sets. And these data sets had to be turned into a solution where I could start answering questions and allowing decision makers within the South African Power Pool to start answering, where can I place the next power station? Where can I build a transmission line which goes from one to the other? This brings me to a topic that I'm quite passionate about, and that is that of spatial data accuracy and the issues that we have when we're trying to understand the value of data. There is no such thing in my mind as inaccurate or accurate data. We have useless or useful data. Because my useless data might be extremely valuable to you. And it depends on your use case and what you're trying to achieve. So let's look at this slide behind you. Now I'm going in a clockwise fashion from the top left of that cone, where we start talking about your traditional spatial data accuracy issues, such as relative accuracy and absolute accuracy. So how well have we placed that point on the ground? We then talk about things like precision and resolution. Those are terms that we use in the remote sensing space. And then we go on to some of the things like, what's the topology requirements? That's under my logical consistency, and how are we going to capture this data as points, as lines, as polygons? How are we going to structure it within the database? Things like metadata I don't even want to go at, because it's one of those terms we keep on talking about and none of us are really embracing what the value of it is. But it's about what lineage, what's the source of the data, who's allowed to access it, how did we process it, and then things like standards. What standard did we use when we made the land cover, as an example? And then things like attributes. Are the attributes good enough? Remember, I had 12 sets of data from 12 countries that needed to be processed. Some were brilliant. Namibia and South Africa, we got very good data from NAM Power and Eskom. When we moved up into some of the other countries like Malawi, I got very limited information. Things like currency, how up to date was the data? And I'm purposefully finishing on the one which was the most important, and I think sometimes we discount what the value is of the completeness of the data. It doesn't matter how accurate the data is that you have in your database if you don't know what data you don't have in your database. So if you are mapping street poles and you've captured them all to 0.5 meter accuracy, but you're not sure you've got all the street poles in the town, I have a problem. So we had to make sure that the data we had was as complete as possible. What we did is we needed to create decision support tools, things that decision makers could use to start doing this analysis. And the approach we followed was to build a grid. The grid was a 2.5 by 2.5 kilometer grid across southern Africa. Now it sounds extremely coarse, but I had 3,000 kilometers east-west and 4,500 kilometers north-south, 1.4 million grid cells, starting to compete with what Sean was talking about earlier. And what we did in each one of those cells is said, there's a water body, there's a road, yes, no, yes, no, yes, no. What's the population? Is there a mine? And we started populating this data into this grid. And this grid became our decision tool. We used a solution called the Rapid Impact Assessment Matrix, which is a tool to understand impact. And because we had all these yes-no, is it within a natural area, is it within a biodiversity hotspot, etc., we could start understanding the implication of building a power line. So if we look at the left of the slide, we're talking about things like what's the impact on water, something very important in the southern continent. What's the impact of erosion? In the middle, we've got what's the impact on wetlands, what's the impact on vegetation, what's the impact of biodiversity and protected areas. And then finally, and sometimes some of the most important on the right, was what's the impact on human settlements of building a new power station? What's the impact on population? Tourist areas, because they're a source of income, cultural areas, agriculture, corridors, and then land tenure. Because in some countries, land tenure is very important. In other countries, maybe it's less important. So how do we take all these factors and start bringing them into effect? And here we use another tool. So we start understanding what's the impact. Is the impact important? Maybe it is, maybe it isn't. If you speak to Craig Beach and say, we have to put a power line across the Kruger Park, he will say no. But if you were the person who didn't have power in that area and you were waiting for a power line, maybe it would be important to you. And we have to trade off on all of these different factors. What's the magnitude of that? If it's just one power line going through an area and it's 1 kilometer, it's maybe not a big impact, yes or no? Is it a permanent impact, or will the grass grow back after we've done whatever we've needed to do? Is it reversible? So we've had to build roads to build a dam, but when we finish building the dam, the area will go over. And we had to understand each one of these factors using a group of specialists in the field to understand impact across southern Africa. And then finally, do all these things add up, or do they balance each other out? So what's the cumulative effect of all of these? And the final product was a map that you see on the left. And that map is those 1.4 million grid cells. And then I've color-coded them by their impact. So what would the impact be if I started to build infrastructure or power infrastructure in the area? So yes, so what does that mean? Look at the left. I'm able to give this to a decision maker to allow him to say, find me a route which typically follows a road, doesn't cross a national park, doesn't cross the biodiversity hotspot, could be near mines, could be near urban areas. And within 2 or 3 minutes across the southern continent, he's able to understand where he could place a power line. And he can run these scenarios. He can take the nature reserves out, he can put the nature reserves back. He can take out solar, he can put back solar. And he can start understanding the implications of his decisions. And this is where the power of the system came, because it wasn't the GIS specialist who had to do this. It was the decision maker planning a route. The final comment is he was able to draw a line. So here we have if we built a power station in the middle of Namibia, we routed it through Khanzi and brought it into the north of Gauteng, what would that implication be? And we were able to pull reports like the report on the left, illustrating the impact of that power line based on all the factors that were important. This takes about 3 or 4 minutes to run. We are then able to draw the line again and run the report and see if we're able to influence the values we got. Can we find a better alternative? And what we did is we took 72 data sets, put them into a structure which had allowed decision makers to start making decisions. Thank you very much.